So this Thursday, so one announcement is that this Thursday evening, there's the Information Technology Leadership event. So just right out in the lobby, opportunity to meet some people in the field. So good networking opportunity if you have the evening free. All right, what else in terms of announcements? We have a test coming up next Monday. We'll be on the Flask material. So get those labs done. I'll probably give it, at least before I gave it in 2 parts. One of the topics is sessions and cookies, and people get confused between sort of interacting with form data and sessions, because now there's 2 ways to pass the information, through the session and through the sort of the form. And you can do a mix of both, but it gets a lot of people confused. So I'll probably have something that's mostly just session cookie and something else that's more about forms. And so I'll give you 2 things, which might seem like it's making it harder, but it will make it hopefully easier, that you won't get confused between those 2 different ways of passing information. Catch up on my attendance here. All right. Okay. And before I ask if there are any questions, and you don't ask any, I will ask myself 2 questions, things that tend to pop up. In this first 14 in the session, this is the part where sometimes I only ask for sort of a session on this first part on the email. And so there's a session way to pass information and a form way to pass information. And that is what tends to confuse people, probably because I'm confusing on it. Just open my notepad. When I do that. Change my mind. I'll move them over to 341 /V and V. Code. So let me see the session. So here I did a redirect, and so I wasn't passing any information, because I was passing the information, all the information I had was session. And so you can do that with a larger form. You just have a lot more session variables. And one of them is an array, and I didn't show you an array, but you could just sort of Google how to do a session array. But let's remind you, in one of the other forms, like Five Guys, where's app FG. So here's where I'm going over to the handler, and I'm not passing any information other than by session. But let's remind you of, here's me sending information, and here's me sending some information from the form. Result equals results, where result was the request form. So you can do both. I've done one in Five Guys. I've done one in my session, but you can do both. So in that pain reliever thing, you can do the email as a session variable and ask, and you can send the email twice. You can send the email as a session variable and as a form variable. So that is one possibility, or the other possibility is to send everything by session. So that is one way in which I've managed to confuse people regarding sessions, that when I did the session, where was it? App session, I lost it already, app session. I didn't send any information other than by session. But that doesn't have to be the way it is. I can have session information, which will be passed, and also send like form information. So that's one way in which I think I've confused people in sessions. Now I have too many things open. Let me close everything and point out the other thing where I don't know. I think maybe I was confusing. Here, I don't think I was confusing, but still, I managed to confuse people. Forms PY app Nobel. Oh, it's the handler in the Nobel Prize. Nobel form handler. Okay. So in the Nobel Prize, the JSON you get from the API was an array within an array. And so one here, I'm explicitly asking for one element of the array. So that got rid of one of the arrays. And then here I'm looking at laureates, which is a second array. And that's why I have a for loop. So I'm looping over the laureates. I'm looping over the winners. And then the winner is an object. And so this inner loop is, I'm using the items property to turn the object, or probably in Python language, a dictionary. I'm turning it sort of into an array by using this items property. And then I can have access to the keys and the values. So that's me saying, I don't know what the keys are, show them to me. If you know what the keys are, you don't need this loop. You can just sort of say, I want this key, I want the image key because I want to show the image. So one, the XKCD API, the JSON it gives you is just an object. There's no array whatsoever. So there's this outer for loop you wouldn't see there, because this isn't a loop over an array and there's no array coming out of that. So you would not see this outer for loop. You would only see the inner for loop if you want to do this thing where you're discovering the keys and the values. If you just want to explicitly use a key and a value, you won't have the inner loop either. So you've got to look at the JSON and know whether it's an array, whether it's an array within an array, whether it's just an object, no arrays whatsoever. And then you also have to know what you're doing with the information. Am I just doing this discovery thing where I'm looking, finding, asking it to tell me the keys and the values? Or am I using explicit keys and values that I know and I'm going to use them the way I want to use them? So one, you have to know what is in the JSON, and two, you have to know what you're doing with it. So a few people were confused there. I blame them. On the other one, I blame me for only sort of never showing you a mixture of sessions and form data being passed back and forth. I did it one way or the other way, and people thought it was one or the other, but it can be both. Okay, so there's me asking myself questions, and people have asked me, but not asked me privately rather than here, but now I've done it for the recording. But let me now ask if there are any questions. Okay. So I made my announcements, information technology leadership event Thursday, and test coming up next Monday. And nobody asked any questions, so I'll move to new material. So we're in the SQLAlchemy material, which will be not until test 3, which will be in the finals week. Here's the final exam schedule on the portal. And when do we meet? Monday, Wednesday, 12. So we're Monday at 12. So that's, we'll be on the 13th for the final for this course. Okay. So, all right. So we did on lab 16 a week ago, we introduced SQLAlchemy. We installed it. Again, Flask is not necessarily an easy install. Things can go wrong. Make sure you don't wait to the last minute to set that up. And then in this case, we added Alchemy to SQLAlchemy to it and wrote sort of a one table database. Then on Wednesday, we had 2 tables and there was a relationship, and that was a one-to-many relationship. And today we're going to do many-to-many relationships. And that's sort of it for databases. There's a one-to-one relationship, which is fairly boring. And I just don't use them a lot. But once you mastered these 3, then you have the database under your belt. And then you're ready, then we'll be ready soon to start interfacing to the database. We'll start putting Flask and SQLAlchemy together. Okay. In my first example, it's going to be a review of last Wednesday, in that I'm going to set up some tables for my Beatles database. And in the beginning, I'm going to have 2 tables, and they're going to have a one-to-many relationship. And then I'll add another entity, and that entity will have a many-to-many relationship with one of the other entities, and we'll show how to do that. Okay, so here is my Beatles database. I'll put it in 341 and SQLAlchemy in the VENV. Pasting it in there. I'm going to open up the folder of not the Flask, but the SQLAlchemy VENV. And I'm going to look at the Beatles. So there's just one Python program right now because I'm not doing any interface yet. It's just to make a database. So I'm going to have a database. I'm going to have 2 things. So over here in Python, those things are going to be classes. Over in the database, we'll probably refer to them as entities. And they're going to be, the data is going to be written into tables. And the 2 things we're going to be talking about are albums and songs. And this is going to be a one-to-many relationship. So again, I'm going to start asking you soon to sort of tell me about relationships. And this is the style of the sentence I want you to, there will be 2 sentences I want you to write to describe a relationship. and they always start with a or an, and then it moves on to, and then the other side has either a one or many as it may be appropriate. So I'm going to assume that a song is on one album. I'm going to ignore the greatest hits albums. So if the song comes back around on the greatest hits album, I'm ignoring it. I'm saying this is the song is on premieres or whatever on one album. Okay. And then an album has many songs. That's pretty much the definition of an album. So if I read the relationship in both directions, always starting with A and starting with one entity, and then starting with A or an, and then the other entity, and then over here is my one or my many. A song is on one album, an album has many songs, that makes it a one-to-many relationship. Remember that our basic sort of fundamental approach in databases is that we're sort of filling in something that looks like Excel, some kind of rows and columns. So a row is a record of information about something. And then it consists of columns or fields. And what goes into a field should be sort of a single thing. So I can put in song, I can put the one album that that song belongs to. But for an album, I cannot put the songs into the database that way, because then I'd have a list of songs and that would violate my rule. So I don't want any lists in the columns in a database. So I will have my song will have an album foreign key. My album will have a relationship to song, but that's not where the foreign key goes. The foreign key should be a unique thing and it belongs with the one. So a song having one album, that means that's where the foreign key goes. And then the foreign key makes the relationship. And we will just say that the album has a relationship. That's something that you wouldn't see in the database, but here in code. Let me mark that down. Okay. All right, so here we go. Just the standard imports. We're going to have all of our usual stuff to make a database. Sorry. Okay. And specifically, we're going to have a foreign key and a relationship. So that's the stuff to make the one-to-many relationship. I'm going to work in memory at first. I usually sort of build up, and so I start with the database in memory. So as I overwrite it, I'm not adding extra records. And then when I think I have what I want, then I'll move it over to a file. And then if I write on the file and I've made a mistake, then I can just, delete the file and start again. Okay. But what we'll try to do ultimately is separate out loading up the database from querying the database. We'll try to do some separation. So then I can load the database on one Python file, and then once the load is succeeded, then don't load it again, and then go over to other Pythons and run them. But since if they're not writing the database, I don't have to worry about sort of overwriting the database. Okay. Anyway, so for now I'm working in memory, so I don't save anything. All right, I'm making an album class. The name of the table over in the database will be album. It's going to have an ID. The ID here is going to be a string. I'm going to make my own ID rather than do an integer and have it auto increment. I already had some data file from years back, and I had, for the albums, I had codes like just sort of like the first letters of the name of the album as sort of a key for the album. So I had like, instead of please me, I had PPM. So I already had in my data that was pre-existing, I had an ID. It was not an integer, so I did not choose integer. So it doesn't have to be an integer. It often is an integer, and it often gets auto-incremented, but it doesn't have to be. The album title is a string. There's an image file, that's a string, and then there's a relationship to song. Song connects to a table that is called song over the database. It has an ID. This is an integer and will be auto-incremented. The song has a title, and the song has an album ID, which is a string, because it's got to match up to the other ID in the other table, so they must match. So over in the album it was a string, so over here it must be a string. And it's a foreign key connecting me to the album.id. This is the table, not the class. The concept of foreign key is relating to tables. And so you put in here the name of the table and the name and column of the table, not of the class. Start everything up, including a session. I'm going to have read stuff from a data file. I have a data file of Beatles albums. Here's the Beatles album. I'm using CSC, comma separated variables. It's got that code, the title, and an image. So I'm just doing my standard old stole it from the beginning of class, read a CSV file, split it on the comma, and I am putting together the pieces of data to make an album. I'm adding it to the database. I am committing it and flushing it. So this means I have my album data created, and I have, by flushing it, I have access to it. And now I'm looping over the Beatles songs. So here's the Beatles song, which has a title and then a code for the album it's on. And so I'm looping over that file and splitting it up, and I'm reading in the song and I'm reading in the album ID. I'm adding the song and I'm committing it. So now I have the data, the album and the song data in there. Here were two simple queries of the album table, and the song table, or actually of the album class and the song class. But I decided to do a slightly more sophisticated query, and I'm querying album, which gives me all the album information. I am looping over all of the albums. And then here I am printing out the title of the album, and this little weird thing makes it underlined. Looks kind of crappy, but something new anyway. And then I don't have to query a new, because of the way that Python and SQLAlchemy handle it, I don't have to do another query to get the songs in that album, because albums has a relationship called songs to the songs on the album, so that once I have an album, I can automatically access its songs, which is an array or a list, so I can loop over that and print the names of the songs. And then when I'm done printing all the songs for an album, I'll print an extra little blank line. So here are the results. Here is I guess that's the last album, Magical Mystery Tour. So the album was underlined. The song titles are indented because I have this \T, that's a tab. So this little U0332, that gave me the underlining of the album. this \T gave me the indenting, the tab, and then the \N gave me the blank line between the different albums. So that was fun. So that's old stuff. That's a one-to-many relationship. Now I'm going to add a many-to-many relationship to that. Any questions before I move to the really new material, the many-to-many? Okay. So I'm going to open this one, many-to-many. The data is the same. So I'm not going to copy the data, but I am going to copy, and I made the file name different this time. So I'm not going to overwrite what I have. I'm just going to have a new one. Copy 341 SQLAlchemy VENV. Here we are, Beatles 2. Okay. So this one, there's going to be two relationships. I'm going to add the artist information. And I'm going to have, I'm just going to hard code it in. There are only 4 Beatles. And so I'll just hard code that information in. And I have the one-to-many relationship we talked about before. A song is on one album, because I've ignored the greatest hits albums, and an album has many songs. So that one and that many are up here, the one-to-many relationship. Now I'm going to add artists, and we are going to have now a many-to-many relationship. A song is written by many artists, and by many we mean more than one. So many just means more than one. So the Beatles songs tend to be, some of them were generally written by both Lennon and McCartney, and many of them, most of them are just attributed to the two. But so the song was written by often 2 people. So that is a many, it's not one. And then the artist wrote many songs. They wrote a lot of songs. So that is, so in this way of writing it, we always write the sentence in both directions, start with an entity and then start with the other entity, always start with a or an. A song is written by many artists, and artist writes many songs. That makes it a many-to-many relationship. And then I say down here that a many-to-many relationships are made by having what I'm going to call a bridge table. There are a number of names for that table. I'm going to call it a bridge table. Remember that our rule in database is that the thing that you're going to write, the piece of data that you're going to write into a row. So you have rows and columns, and so that sort of identifies for you a cell, a single cell, and you should write just one thing in the cell. So it shouldn't be a list of things. So I cannot write the songs in the artist table because there are too many of them. And I can't write the artists in the song table because there are too many of them. And so I make a new table, and basically each entity has a one-to-many relationship with that bridge table. And so the bridge table is made up of foreign keys. In this case, it's going to be made up only of foreign keys. Occasionally, it has its own additional properties. But for this example here, the bridge table is only just a bunch of foreign keys. But you remember our rule that the database cannot have cells with multiple things in them. And these were both many. So up here in the song is on one album, and an album has many songs. This one is where we identified that's where the foreign key goes. Well, there was no place down here to put the foreign key. I can't put the foreign key in song because there were many artists. I can't put the foreign key in artist because there were many songs. So neither of those gets the foreign key for this relationship. I need a new table that has two foreign keys. It may have other things. It won't in this case, but okay. And that is what I'm going to call a bridge table. Okay. So my imports, the big new thing for you to note in my imports is table. Instead of making everything else I'm making is a class, I'm making an artist class and an album class and a song class, but I'm going to explicitly make this thing a table rather than a class. And so I'm bringing in something new, table. I'm going to actually write the database this time, Beatles. And here's me dealing with that class. I'm dealing right away with the class. And this is the class that is going to establish for me the many-to-many relationship between the songs and the artists. So I'm going to make a table. I'm calling it the right table because it's the artist wrote the song. Probably come up with a better name than that. There's going to be a column that is the artist ID, that's a foreign key to the artist table. And that was an integer, or will be an integer. And the song ID, which is an integer, and it's a foreign key to the song. So this is just going to be a table of numbers. Okay. Here's my album. Album is the same as before. I had a string ID because I had the pre-existing ppm, things like that. So I'm using string IDs, and it was the primary key. I have the album title, an image for the album that I'm not doing anything with, but I had it in my data, and I have a relationship to the song. That didn't change. I have a song class. Table name is song. It has an ID. It's an integer. This one is an auto increment. The song has a title. The song belongs to an album, so that is a foreign key. So that much is what we had before. But the song also has this new many-to-many relationship to the artist, but I connect it, so I'm connecting it written by, that's how I'm going to name this relationship that the song is written by. It's a relationship to artist that works through the right table. So that's my connection to the other entity through the right table. Now here's my artist class. So I have a table called artist. Have an ID, which is I'm auto incrementing. I have a first name column, a last name column, and I have a relationship to song, which works through the right table. I start a session. I do my file thing. I make the albums from the Beatles albums text file. I'm making my songs from the songs table, committing, flushing, okay. And now this is hard coded. I'm making the Beatles, John Lennon, Paul McCartney, George Harrison, Ringo Starr. And now here is me sort of hard coding some of those right table relationships. So first I have to establish my artists, and I establish my songs, I establish my artists, then I can make the relationship between them. So Lennon and McCartney wrote the first song. I saw her standing there. So here is a 1. That stands for, how did my right table go? My right table is the artist and then the song. So the artist and then the song. So here's Lennon writing the first song, I saw her standing there, and McCartney also writing the first song, I saw her standing there. The next song is Misery, and Lennon wrote it and McCartney wrote it. 1, 2, 2, 2. Ask Me Why is the sixth song, and Lennon wrote it and McCartney wrote it together. George Harrison tended to write alone, so there is artist number 3 writing song 18. He started later than the other 2. So that is the data. Okay. Here I'm looking at the song information. I'm looking at the first song, and then I'm looping over the people who wrote that song. And here I'm looking at the first artist, and I'm looping over the songs written by that artist. So I Saw Her Standing There was written by Lennon and McCartney. Lennon wrote the following songs: I Saw Her Standing There, Misery, Ask Me Why. A lot more, but I was too lazy to put them all in. Okay. So that is a many-to-many relationship. There's at least another way to do it, but I have been doing it through this bridge table. And then each of the two things, the song has a relationship to the artist through the bridge table, and the artist has a relationship to the song through the bridge table. So that is how we do, at least a way to do a many-to-many relationship. Let's show what you have to do, which is like the same, but change the data. For the most part. So you're going to make a little quote database. So you're going to have authors and quotes and subjects. The relationship between author and quote is going to be one-to-many. An author might have written many quotes, but we're going to assume that the quote is by one author. Sometimes a quote may be attributed to more than one person, but we're going to keep it simple and say the quote is by one author. So Mark Twain may have said multiple things, but these things were said, at least originally, by Mark Twain. So that's a one-to-many relationship. Then a quote is going to be sort of have a subject or a topic or something, some kind of category. And so it's not going to be necessarily many subjects, but it's going to be more than one subject. So there's a quote, "Don't let schooling interfere with your education." And we'll say that that might have, it's humorous, Mark Twain, and usually said funny things, but it's also about education. So we'll say that's got two subjects. But then humor, the subject, there's, you know, there's more than one funny quote. Don't let schooling interfere with your education. That was Mark Twain. That's sort of funny. And I had a perfectly wonderful evening, but it wasn't. But this wasn't it. I really screwed up that joke. Was by Groucho Marx. So I cannot put the foreign key, because I'm having multiple subjects. I can't put the foreign key of subject in my quote table because I have more than one subject, or a quote may have more than one subject. And I can't put a quote ID as a foreign key in my subject because there may be more than one quote that falls under humor. So I need this bridge table. So it's a many-to-many relationship, and I am going to need the bridge table. So a quote may fall under many subjects. A subject may have many quotes. That makes it many-to-many. So you're going to basically follow my example, but switch out Beatles and songs and albums into writers and quotes and subjects. So you should have a few authors, at least two. You should have a few subjects, at least two. You should have some quotes, 4, 5, 6, or something. All right. Questions? All right. And no questions for the recording. I will update my